Hello there. It's time for a somewhat impromptu video that's not really scripted or anything, because I just wanted to talk about this. I now have a proper electronics workbench. Like, this is a real workbench. I can do actual work at this now. There's places for my things to go. This rocks. Whoops. And it's just something I've been putting together for the last week or so. I wasn't expecting to get one of these. I was able to pick this up locally for near enough free for how much these things actually go for. And this is like a real one. This light's blocking it, but there's power outlets all over it. And the light I'll talk about in a moment. But this is a true, honest, real workbench. I even have like grounding here with an ESD strap. My ESD mat is properly grounded. The whole thing is just solid. This is a metal frame. This thing rocks. I'm so excited. So today we're just gonna take a look at it, take a look at the stuff that I'm gonna be working with going forward on projects. I figured we might as well take a look at some of the things that I use. It would help if I turned on the master switch there. Just so you can get an idea of what equipment I use when I work on things. Most of this hasn't changed, but some of this I really haven't been able to use, like my 16500C, just because it's really suited to a work setup like this, and we'll take a look at why. But yeah, I'm very excited. Okay, let's start with some basics. I have no idea what brand or model this bench may be. I don't even know if it would have had one. Based on the construction, I'm thinking this thing's actually really old, but it's a, I think, 36-inch high, 6-foot wide bench with 30 inches of depth, which is probably going to be pretty average for a workbench. Now, there are two main components to making a workbench really nice to work with. One of them is the main work area below. Now, as I mentioned, this is a 6-foot wide table and is 30 inches deep. That is a lot of workspace, and it gives me plenty of room to put everything I need. Now, an additional feature to this work area is that it has outlets built in all around it. Now, unfortunately, the light I put on there is obstructing those. I could have mounted it a little further back, but for filming purposes, it's better to have it further forward. You will also notice that my ESD mat does not fully cover the work surface, but that's fine because over to the side here, there is a drawer and a cabinet, so I couldn't really work on there anyway. So I'm just gonna go ahead and use that for storage. Now, as much as I enjoy the work surface being nice, the shelf above is really what sets this workbench apart from just an average table. This is where you can put all of your test gear and other monitoring equipment and just really handy things, and I guess storage because I'm out of floor space. But the real benefit of this is to have all of my test equipment right here up above my work surface. Many of these things are really big and bulky, like my HP 16500C there. This thing has a footprint of 19 inches wide and approaching 30 inches deep. I mean, well, maybe probably more like 27 inches deep. It's really big. So having it on the work surface just kills the entire workspace. So having it up above really changes how I can use it, and that is why I'm so excited here. So that's pretty much it for the workbench itself. There's really not a whole lot to it. It's a table and it holds things. It does have a metal frame. Actually, I did film installing it in here. I was gonna have it be kind of like a vlog type thing where I showed you how to put it in, but putting that top on the workbench was a bridge too far for filming. So really, I don't think it was worth covering all that, but there's what I shot, and it was with my phone, so it's not tremendous. But let's move on for now and talk about the things that are on the workbench. And starting with the thing that is the most on the workbench, and that's the ESD mat. All right, I'm gonna interrupt myself here for a moment. ESD mats, I tried to talk about why you'd buy one, what they do, how they work, and realize that I think that they don't do necessarily what you think they do, at least not what I thought they did. So I want to just briefly talk about this after having done a bunch of research and asking around trying to get input from people. So first off, researching ESD mats is extremely difficult because almost all of the resources you find come from manufacturers. Now, manufacturers do have to correctly portray their product so that it's not false advertising, but they can stretch it a little bit to make it seem maybe better than it is. So you have to take it with a bit of grain of salt. Now, the other problem is that you get articles like this. Oh, the essential things to know about ESD mats. Awesome. I can't wait to get into the meat of this. Oh, that's it. It's really short. And almost everything in this article is bullet points about where you use ESD mats. Really, there's only one sentence in this whole thing that actually tells you anything, and it's right here. As with other forms of static safety equipment, ESD mats serve a twofold function. They dissipate the static electricity of individuals or objects, as well as preventing the buildup of static electricity in the work environment. Now, these are the two possible things that an ESD mat can do: dissipate and prevent, or be truly anti-static. And first off, let's look at dissipate. So here's another manufacturer who is promoting their own ESD mats on this page with the most garish colors for a website you could almost imagine. The only way this could get worse if the text was white. But anyway, they're showing here that they've measured a technician walking up to the mat with a 2 kilovolt charge. They touch the mat and it discharges over about a second, which is about what you would want so you don't have a really harsh impact onto something or yourself. That's how you get the spark, is that you discharge immediately. But here's the thing, okay, if we go back, these exist. This is an ESD strap. The instant you put this on, or even just touch the grounded bar, you no longer have a charge, and you won't need the dissipative capability of the mat. So that kind of puts that out as being necessary. They're talking about like a big clean room environment where technicians are going to be moving from one station to another and they can't wear an ESD strap. That's why you would do that. And then they talk about here that technician puts on a heel strap, which would ground you by your ankle to the ground. And that's what you would do in an environment like this, where an ESD mat could be more useful. But again, at a static location bench, and I shouldn't stay static like that, at a dedicated bench location, just put on the ESD strap and you'll be fine. But there's one other aspect of this that first page mentioned, the preventative. Now, the mat here is going to have multiple components. One side, like this, is going to be conductive. Now, my mat measured here at 10 mega ohms per square, and that's per square because it's sheet resistance, and it's different because the current can either go in a straight line or go around, and the straight line and around can equal out depending on how far it is. Sheet resistance is weird. That's a whole other thing. Anyway, but the top is essentially non-conductive, and you need a weird device that you kind of plonk down on the mat to actually measure the conductivity through the top. Now, the top on mine's vinyl, so it's not like a truly conductive material, and it's not infused with, well, I mean, it's probably infused with something, but it's not like really conductive. You can't just put the probes on it and measure it. So it's difficult to qualify the capability of a mat, but the whole point here with the conductive bottom and then the insulative top would be to prevent the buildup of static charge in the first place in your work environment. So that's a potential real benefit that an ESD mat can make or can provide. There are problems though. This ESD mat is I bought it as high temp because I wanted to solder directly on it. I like soldered it, but I wanted to be able to solder on it, but I can't because it melts, even though it was supposed to be high temp. It's vinyl, it's not silicone. So I end up soldering on this pad here, which is a kitchen thing. It's actually silicone, but then it's insulative. And the device under test or rework isn't grounded through the mat, so I'm losing that functionality. So it's just something else to know. And then I also wanted to point out, if you build your own helping hands and make them out of line lock or something, and especially if you insulate the tips like this and then don't ground a wire through the line lock, you're invalidating any ESD precautions anyway, unless you ground it some way else by like adding a separate ground connections. Just, this isn't going to work at all. You are completely isolating it and then eliminating any grounding protections you've taken. So yeah, whole grounding anti-static protection thing's kind of a mess. So I wanted to come back at this rather than let myself wander around here talking aimlessly. So yeah, hopefully this was more informative because there is just a lot of well, there's not a lot of information. There's a lot of bolstering of products, and I'm not sure how necessary an ESD mat is for someone in a home environment like this. The preventative capability, fine, but the instant you connect the device to a power supply or yourself to ground, and yourself to ground, you're at the same potential, so I don't know. But anyway, that's pretty much it for the ESD mats. Now let's get back to this and talk about, I guess, my lights up next. Okay, now let me really quick mention the light I have here. Now I mounted this further forward because the original light fixture that was in here was mounted really far back on the other side of this bar that has these outlets on it. And while that would be mostly fine when you're working on this just as work, for filming that sucks because it means that shadows are cast forward towards the camera. So if anything, I should even take this out and like hang it slightly above the whole work area. And I may actually do that because this thing is a little bright for this area. Let me adjust the camera. If I widen this out, you'll actually see how much darker the rest of the room now appears on camera compared to the well-lit work area. This is a 5,000 lumen LED light. And while I do like it for actually doing work here, I think this is really, really nice. It may not stick around forever. I'm not 100% sure. So let me see if I can quickly demonstrate this by just turning this on. Yeah. Can you see that flicker? I don't know if it's, well, now the thing's charged probably. This thing has like no capacitance at all. This is a hyper tough light. I mean, I don't really want to link to it in the description. I don't think it's a very good purchase. So I'm not sure. I was just trying to get this thing working and usable, and this is kind of a necessity for that. So I'm not 100% sure if I'm gonna use this for filming. I wanna see how it looks on camera while I'm doing this stuff today. So there's that. But yeah, that's the light. It's 4 foot long, 5,000 lumens, which is just ridiculous. If you don't film at the right shutter angle, you're going to see these lines appear. Now these lines are from the rolling flickering that this light is doing. It's a 60 hertz light. So you're seeing those weird lines because the camera shutter is not aligning with the light. So to shoot this and have it look kind of normal, I'm actually filming at 60 frames per second, but the shutter opened 1/60th of a second so that it perfectly matches the light. So that's, I'm used to filming like that for CRTs, but now it's a requirement for this light. I can't film with any other shutter speed or anything else here, which really, really sucks when I'm working with my phone. I don't know what would be better. Obviously, if it had bigger capacitors in it, that would be nice. But yeah, the brightness does not offset the other problems necessarily. But I don't really regret the purchase, although I will admit I did look for my receipt and just in case I wanted to take it back. But I don't know, I'm gonna roll with it for a while. It was like 20 bucks. I mean, that's the only real saving grace. It was really, really cheap. I have more money. Well, that's really cheap for lights. It's not a high quality light, but you know, it's a lot of it. All right, now let's start getting into the gear I will be using working forward. This is my soldering iron. This is a Metcal MX500, and I've actually done a whole video about, I can't remember if it was this one or the other one that fully worked. I've ended up keeping both of them. This one has been in here at my electronics work area, and the other one's just been at my desk for extra soldering where I don't want to have to get up and come in here, mostly because this work area sucked, so the other one may not be as necessary now that this is much nicer. The tips are, I mean, I highly recommend you watch the full MX500 video because I talk about everything there. This is not a temperature controlled soldering iron in the regard that you can adjust the temperature. The tips themselves are calibrated so that the temperature is fixed for each tip. The majority of my tips have now failed. I actually need to buy some more, which sucks because they're expensive. They're like $20 to $30 a tip. And I'm not sure that Metcal themselves are actually making them anymore, so I'm going to be getting Thermaltronics brand tips most likely. So there's that. But yeah, that's pretty much it. Watch the video on that, although I will mention this. I get a lot of questions about this when it shows up in videos. So this is my brass wool holder because the base for the Metcal iron does not have brass wool right there. It just has the sponge. This is a votive candle holder, just a tea light candle that I crammed a cheapo brass wool holder into. The benefit of this is that it's super heavy and I can go at it really aggressively and it's not gonna move, especially on the sticky ESD mat. So I really, really like that. This came from a thrift store. No idea what it would be called, where you could get one, but it's made out of glass. So that's that. I always get questions about that. So there you go. All right, let's move on to the DC power supply I use. This is a BK Precision 1711. Yes, haha, pew pew. This is a, I believe it's 60 volt power supply. Yeah, 60 volt. There's a label on the top, 58 volt 2 amp max. I'm not quite sure why. Maybe someone measured it. I haven't actually bothered confirming that. It's a linear power supply, so it doesn't use switch mode inside, which is really handy in some circumstances. So it's nice to have this. I do need to get a more modern switch mode power supply. I really want a HP one to go with my 34401A that we'll look at, because I would like them to all be SCPI programmable. I'm trying to just go all HP, but this is really nice. For its simplicity, I usually follow this up with a parallel multimeter just to confirm the output digitally, because I don't necessarily fully trust these, but it's really nice. It's current limiting, so I can set a maximum current. Has a true earth ground connection that is not always permanently ganged to the negative output, so this is really nice. It's a dual stage current, so there's 2 rows on the indicator here. When you're at low, you're on the bottom side, which only goes up to 1/2 amp, and then when you're at high, it goes up to 2 amps. So yeah, I do like it. It's just not the best. And then I'll briefly mention this. This is I believe a Hacko knockoff a fume extractor, another thrift store find. This was not a thrift store find, and neither was the soldering iron, but this was. And it's just a fume extractor, nothing really fancy. Takes a pad, there's a fan, solder fumes go through this. You're supposed to check it every now and then. You can start to see some lines there. It's getting used a little bit. I don't usually use this when I'm filming because it's really loud, because it has to suck all the air through that porous material. So yeah, you may not ever really see this get used just because of that, but when I solder without the camera rolling, yeah, this is a good idea. All right, I'll just quickly wrap up this side because there's not a whole lot to see. The keyboard here is connected to my logic analyzer. Again, we'll get to that when we get up there. This is just trash, needs to get out of the way. I have a clock. This is the GE. I forget what the part number is, but it's not quite a flip clock, but the dials, digits do flip. Super glue, or hot glue gun. This just came from Joann's or something. I kind of like it because it detaches and then relies on the thermal mass inside of the glue gun itself. We got a box full of random stuff, mostly heat sinks. This is a drawer bin full of resistors, except when it's not and I forget and lose them. Behind that is a random assortment of things. These are 2 sandwich tubs full of serial connectors, and then just some random stuff, including bits left over from ATX PC Junior kits that I need to reorder very much. Yeah, I need to do that. That's now that I have an actual proper workspace, it's more likely to happen. Okay, so I'll mention really quick, I'm using the underside of the workbench area down there as storage because I just need all the storage space I can possibly get. And this eats up a lot of floor space to not really use it as storage. Is part of why that cable drawer thing is up there. Now, this thing has 1 drawer, and I'm extremely afraid I'm gonna forget it exists. So I've been putting everything in there that I use. I mean, my iFixit kit that's missing the driver right now, some random project bits, my tool set, a humongous magnifier. So I'm just trying to keep as much stuff in here as possible for the time being. So I actually remember where it is, because I've worked with benches like this in the past at actual jobs, and it's so easy to forget what's in here. So I just wanted to put everything in here. So all my loose tools, with the exception of the screwdrivers that are near the Metcal, which is just a little thing I have, are going in here. I figure I should probably actually mention this as well. This is a Soldapult solder sucker thing. So I generally don't like these, and I don't have a desoldering gun. This is all I've got. I looked around to see what people thought of as the best solder sucker, and this was it. This was the only one that was really favorably reviewed, and it's way better. It's miles better than the cheapo metal ones. So if you want a decent solder sucker, a Soldapult is what you want. I will link this below because I do kind of like this. So yeah, just there you go. That's that. Down here is a cabinet that's not the easiest thing to get to, not just because I have a Smith Corona in the way. It's just really far down. It only has one drawer in it, or one shelf. I'm keeping some things, the spools material. Here's some reefer caps, reefer cap replacements. There's a reel of SMD capacitors. There's a thing. Okay, so I got questions about this. When I cleaned my Burroughs adding machine, I used this to go through between the keys. So it's a big fluffy yarn that I could thread between. This is like super not ESD safe, but a mechanical adding machine, not a problem. So basically think of this as gigantic floss. So if you need to clean in between some stuff, some really big poofy yarn, it's not a bad idea. Oh, and here's where I keep assorted lengths of wire. Okay, I have a couple of other things that are in a shelf down here that you may have seen earlier, and I'm just going to go through those one at a time because these are also ad hoc type things. This is the only tool that's not getting put in my drawer for no particular reason, but this is my dial caliper. Now, I prefer things not use power when they don't need to. Surprise, surprise, says the person who collects mechanical calculators. But this is... Actually, I've really enjoyed using this. This is, I guess, an Anytime Tools brand. I have no problems with this thing, so I would recommend this if you're looking for a set of calipers and don't want them to be electronic. So I do really like that. Next, we have a multimeter. This is my go-to portable multimeter. This is a Fluke 287. This is not an inexpensive multimeter to get into. It's good. I would recommend it. But it's not inexpensive. So it better be. So yeah, that's pretty much it. If you want to watch like dedicated videos on this thing, you could, but it's really good. That's pretty much what there is to it. There is a downside of this thing, actually. It's slow as all get out. That's why I mostly use my 34401A, because it's super fast by comparison. I like to make a comparison of things that there's two types of powerful vehicles. There are sports cars that are quick, and then there are semis that can haul things and do a lot of work. This is a semi. It does a whole lot, but it takes a lot of time to do it. It can log data and output it over infrared on the top. I'm not quite sure why it couldn't have been an electrical contact thing. Maybe because they wanted to be able to force you to buy their cable, which I haven't done. It's got a lot of functionality, but it's slow. This currently has a blown 10 amp fuse, I believe, because I thought it would be cool to measure the phase of outlets, and I think I did something wrong, but I don't really need 10 amps, so I'm not that worried about it. Okay, up next is something that's really old for this channel. This is a DER-EE LCR meter. I actually have a whole video on this, so I'll just link that for the most part. It's a capacitance meter. I put the battery in backwards, I fried a protection diode, and I had to replace it. That was the video, but I also went through what this does. You use this for measuring, there was one over here, capacitors. That doesn't matter. You've seen capacitors before? Oh, there it is. You have clips, you got different things. You can measure the capacitance, the ESR, a bunch of different things. It's LCR meter because it's for inductors, but capacitors work kind of similarly for the same thing. So yeah, there's that. Probably do recommend that. I haven't really had any issues with it, although it is expensive. Not super duper expensive. It's like mid-tier expensive. And there are cheap ones, like $5 that can do similar things. So maybe worth looking into those. But yeah, that's what I use for that. And I'll briefly talk about a couple of these. These are Radio Shack multimeters. They're analog. That's their big draw. Now it might seem weird to have these set aside. They're both kind of basic. Well, actually, maybe not this one. This one's not truly analog. Let's just ignore that one for now, actually. This is a true analog multimeter, which means that it does not need batteries, and it consumes a little bit of power when you're using it to move the meter. So there are some instances where this is useful, and we will be looking at one of those eventually, now that I finally have a space. You know, there's a lot of projects I've been putting off that I can do, and that will be for reforming capacitors. And I know a bunch of you are also going to comment in the comments below now telling me how you should not reform capacitors, but I'm on team reform, and I'm not going to really get into it until I do my video on it. So yeah, just know that these will eventually show up, but yeah, not for right now, and not for most work, because they're still a pain to use. This is a really quick one. This is a kilowatt. You plug things in, it measures the power, and yeah, that's pretty much all there is to it. Think of it like a multimeter that does one thing. That's kind of it. You can also get these that plug into a USB. They're not a kilowatt brand. They're like just generic stuff. I don't have one of those. I do really need to get one at some point, though. Okay, this should be interesting. Matter of fact, I will even switch over to the light, and this will make sense in a moment. Alrighty, let's do this. So this is a hot air gun. All right, I've been meaning to get one of these for a long time now, and I have a problem now that I have it. So actually I haven't used this in a video yet. I know exactly what the first project that will be that will use this, but if I turn it on, all right, and the light's gonna kind of give us all the indication of what the problem is here that we'll need. So let's go ahead and turn this up. This thing's gonna basically brown out the power in this room because it draws so much current, something the kilowatt here showed me. So I don't, actually this is doing kind of good. I swear it was doing much worse. Maybe I can use this, I don't know. There we go. Starting to get a little high on the power draw there. So I'm not actually sure how I'm going to use this in videos. Normally I'll just go do this where the microwave's plugged in, because then I can have all the current I need and know it'll be enough. But yeah, so it's a heat gun. Haven't used it yet. It'll probably make its way into a video at some point, because I have a video planned that I needed this for. So that's why I kind of went with the cheap one, just because I need to get my feet wet on it first, and then I'll probably upgrade to a better one later. All right, up first is my ANET A8, which does not get a lot of use, and that's not because I don't like it or because it doesn't work. Actually, just reassured that it actually was everything set up, and I reprimed it with filament. That always is a nightmare on here. Oh man, it sucks. But I see this as a tool. It's not something, I'm not printing knickknacks. I don't want to have it running all the time. I'm not interested in constantly buying filament. So I just use it when I need to use it, when I need a particular thing, which is kind of what this is. And I get way too many questions about this. So let me grab something here really quick. This is a card stand. I designed this to be as universally compatible with different cards as possible, so I can show them in videos in an upright position that looks very appealing. But I get so many questions about this that people wonder where I got it or where can they get it. I designed it and I 3D printed it. I have the file available on GitHub. I've linked to it a bunch of times for people, but I get asked about it so much that I can't respond to every single message about it. So they're there, and I think this is the first time I've actively mentioned it in a video. So yes, these are 3D printed card stands, but I do other 3D printed stuff like the ATX to PC Junior kits. I've 3D printed some other things. I can't really remember what, the Kindle DX joystick, but it's a tool. I don't want to just use it all the time. So there's that. But yep, that's my 3D printer. It does not have the display like it should. I have a video about all the upgrades and different modifications I've done. It's pretty old. It really hasn't changed. It still works, so I don't really feel a need to replace it. I would like one that is made out of aluminum 4040, I believe is what it is, just so that it's a little more rigid and I'm not feeling like I'm gonna break it all the time, I'd really like a Bowden one just to get away from manually feeding the extruder. That's the worst part about this thing. Changing filament is a nightmare. But aside from that, it's fine. I really hate changing filament on it though. That is the worst. So, yeah. But anyway, if you want to see more about this, I have a video. I'll link it in the description. All right, I'm going to skip the 16500C because I want to come back to that last because I want to use the work surface with it. I'm going to very quickly talk about my multimeter here and the oscilloscope there, and I'll just mention this is another one of those Memorex power switches, and I have all of the equipment up here on it, just so I can easily turn it off and on with labels on the bottom that I can see while I'm sitting at the bench, rather than needing to fiddle around with stuff. So yeah, the 34401A, I haven't really done a video about, not the BK Precision Scope either, but I'll talk about the scope first. This isn't really exciting. I mean, it's just an oscilloscope. I don't have, I need to put a support behind this because it's kind of falling off of the back here, and pull it forward a little bit. So it looks a little better. There we go. It's an analog oscilloscope. It's not very good, 30 megahertz, yada yada. So I'm not like, I'm not gonna really recommend this one. There's not a lot to it. I like using an analog oscilloscope for its immediacy, because it's right there. Everything you want to do is knobs. The 16500C, again, we'll take a look at in a moment, is the antithesis of this. Everything is slow on that. So I like having an immediate oscilloscope handy, and this one works out pretty well. So I'm okay with it. It is a dual channel here. If I show ground and move this up, we can do both traces at once. The downside to this, and probably why I don't like using it in videos so much, I think I used this for the CDP, the Sony CD player laser calibration as well. And that kind of showed exactly why this isn't so great, because if we change the timing here, it flickers, and there's nothing I can do about that for the camera, because that's just how the scope looks. Actually, I'm seeing the flicker in real life as well. There's just nothing to be done about it. So yeah, analog scope's not tremendous for video work for that reason. So that's where this one will be better. The 34401A, I'm a little disappointed that it's going to be up here for video purposes, because it's nice to be able to show this in camera. I'll probably use an old camera or my phone or something, just wave it in front of it while I'm doing work. But this is my go-to multimeter. Now, this is functionally equivalent to the Fluke 287 I showed earlier, but it's better, actually. And it's really nice. I like it a lot. I've written software to use it. This has RS-232, GPIB. I think that's it for interfaces, but it's really nice, programmable. I may put the terminals on the probes on the rear. I haven't decided. Kind of like being able to take them off and not having a bunch of probes draped down the back of this. But this has that functionality. I can plug these cables into the rear, push that, and now it'll be there. So it's a really nice unit. I like it a lot. It's high resolution, which I don't really care about. Nothing I do is that precise, but whoops, let's just leave it. But that's functional. I really need to put a extension behind this. I have one, I just need to move it here. But it's really nice. I like it a lot. Does everything DC, AC, current, just everything you'd really ever want. So I highly recommend this. They're not, I don't know what to say these are for value wise. They're old. You can still buy them new. I believe the newest one is the 34406, or might be 34601. I'm not sure. GPIB is now an option. They have USB instead of RS-232, but they're super expensive. Like I've mentioned, other things are expensive. These are like $1,500 new. I paid about $300 for this used, which is just fair. So they are not affordable compared to your $2 Harbor Freight multimeter, but it's really good, which is why I wanted it. And there's other reasons. I can do data logging because of the computer interface and all that stuff. I don't need that for a lot of things, but when I do stuff on videos and I need to really talk about things, I might need to do that. So yeah, that's my analog oscilloscope, which I will personally use, but probably never really show on videos now, and my multimeter. Now, let's talk about this. Okay, now the lighting's not going to be the best for this segment, just because I needed to have all of this stuff on and not have any glare. So, you just bear with me for a moment. Okay, so this is my HP 16500C. I've done a video about this. It's the most recent addition to my assortment of things here. Really quick, this is a PM Model 1009. It's a log RF power meter. It's got a big thing that you pull out and it does stuff. It's broken. It's got a bad power supply. Why do I have it? Because it uses Nixie tubes for the display. And I got it for dirt cheap. Looks like maybe 20 bucks at a thrift store a long time ago. The only reason it's here is because I don't have anywhere else to put it. It's got really nice gang switches that are semi-functional. I don't know. It would be cool to fix it, but I have no use for it at all. It's really not that great. So I don't know. Making it work again is not the most compelling idea. So probably won't ever. I might pull it apart, repurpose the display, in the interface. I mean, it's flat front. It's got nice knobs and buttons. I don't know. Could be fun to make a project out of. I'm not really sure. I haven't decided yet. I'm not a big fan of just ruining vintage equipment, and it's very vintage, so I don't know. But on the other hand, it's pretty useless. So I don't know. Probably way out of spec too. So it's never going to be reliable again because it's ancient. It probably need to be just rebuilt from scratch. So I don't know. Yeah. Anyway. This. Now, I have a really hard time characterizing what this thing is, the HP 16500C. It's called a logic analysis system, but if you've seen my other video, it does like everything ever. It's a whole computer inside. It's got an IDE hard drive. It takes a bunch of cards on the back. It currently has a 35 megahertz state, 100 megahertz timing module, a scope acquisition module with 400 megasamples per second, and a scope time-based card. And I actually have a second 35 100 state and timing card that I could put in there, but I really don't need any more channels for what I do. But it also has a network connection, which I actually can connect to right now here. If I do that, added to the host list, and if I tap this, boom, bingo, I can now control the scope from my computer, which is pretty sweet. I also have this here, which is a keyboard connected to the same thing directly over PS2, and that's because sometimes it's useful to type into this, and if you don't have that, then you gotta type on the touch screen, which is pretty sweet, but sucks. So yeah, a lot of different ways of using it. This is done over LAN. Could be, probably couldn't do X window over other connections, but it's got RS-232, GPIB. It's crazy. This thing rocks. It's so advanced. It's cool. But it's slow to use. So let me go to the oscilloscope card here. All right, let me set it to continuous run, and here is where this is different from the last time you've seen this. So last time I had this up on top of a shelf, and I complained about the length of the probes. It's not a problem anymore, though. I can reach everywhere I'm going to work, and that's because the probes connect to the rear of this. Obviously, they're not on the front, and that's because it is a card-based system. The oscilloscope is actually a card that plugs into this, but now I can go anywhere, so I can actually connect this to the calibration signal on this thing, and then I can crank up the voltage per division here, and we can see what's going on. Actually, just go ahead and get rid of the second thing here. D1, done. Bingo. Now we can see the calibration signal from this on here, and that was pretty quick and easy to use, but it's still not very fast. I mean, it's no analog scope, basically, is what it comes down to, but it's not bad at all. So I'm still getting to grips with using this because I really haven't been able to since the probe length and all that stuff was a nightmare before. But I am getting there. So like one thing I had problems with last time around was logic analysis because, whoa, man, this thing is complicated to set up. So if I go to the state and timing card, I have to set this to timing. I can then do this, but this is only going to show the first 2 channels because it's loading a default from someone else. I need to go through and change this. Now we have some channels. Okay. Whew. Now, it's probably going to be hard to see over there. But this is a set of rising and then falling timings. So I have this connected to an Arduino Uno down here. This is a real OG old one. I don't even know if there's a date code on there. 2014, okay. And I have the probe pod connected directly to it, and I have it running code, and I can actually do a continuous measurement here, repetitive, and now it will reintegrate samples multiple times. You can probably adjust that, but I haven't figured it out yet. And then once it's done its pattern recognition or whatever, it'll show the display, boom, and then it will restart the acquisition. Now, what I need to do is I need to figure out different things about this. Like I need to know how to use single shot triggering. I need to figure out, there's probably a way of displaying it live where it does not have to do this. I mean, I have accumulate off, X pattern. Yeah, I need to spend some more time with it, but now I actually can, which is what is critical here. So yeah, I'm really excited about that because it's just more usable now. It's also really cool. If I go to, man, how can I do this? Can I do it from here? Okay, no, I need to go to, let's see, state timing, intermodule. We're gonna add this group run. We're gonna add, this example didn't work out as great, but you can do a split. There we go. So this is the logic analysis ladder. Let's stop. I can zoom out, you can see that, but then we also have the analog measurement at the same time. So you can do some real fancy stuff with this. So it's cool. I can't wait to play around with it some more. All right, well, that's pretty much it. This is now a fully operational workbench, and I can do real stuff here. I'm super excited to see what happens. I got a few projects lined up that are kind of ready to go and incorporate some different things. I have an SMD repair project with the second Roland SK88, where I'm going to try and replace the CPU in that to see if that fixes this. Oh, actually, you know what? It's right here. So this, we'll see if we can fix that. I have an HP 85 now that I'm going to try and convert over to DC 2000. I think it is the, or is it Quick 40, whichever the slightly taller tape cartridge format is. And I'm going to see if I can 3D print an extension to the capstan metal core, whatever it is, rather than lathe machine a new one, because obviously I don't have access to that. That's some high-end stuff. But if I can 3D print an extension, then either put shrink tubing over that or maybe cave and get some medical silicone tubing, that might be a more viable alternative. So I'm looking forward to trying that. But yeah, just a bunch of stuff that I really haven't been able to do here, that I'm now much more capable of doing. I'm super duper excited about this. I really can't overstate that. I'm so excited about this. I'm not thrilled about the overly bright light that has flickering issues, but that's solvable. It does mean though that if I won't ever be able to have the workspace and the equipment in frame at once on one camera. So like I said, I'm probably gonna have to do 2 camera setups for that if I want to show something or show a test and then show a measurement and change camera settings. It's kind of a pain, but it's worth it. Yeah, I'm really happy with all of this. Have any questions or suggestions? I would be interested in hearing them down below. But for now, I think that's it. Hope you guys have enjoyed this look. This is practically my dream bench. I mean, I don't think that, you know, let me think about this. What would I change? Well, it's really just what I would add, and it's pretty much 2 things. Digitally controllable power supply, like the 3441A. I have my eye on a couple of different HP ones. I'm not sure if I want to try and go for this era or this era. The HP 85 that I talked about, I actually want because it kind of goes with this stuff, although it's even older than this. That's like HP 9000 series era. But I kind of like this. There's a HP power supply that I got my eye on. It's like, I think 100 watts. It's 2U. We'll probably replace this with that. thinking about that. And then I want an HP signal generator, but it needs to be GPIB controllable and be able to do arbitrary functions. I want to be able to just take a sample out of this, stuff it into the signal generator, and repeat it. I think that would be super cool and super useful for debugging stuff. So, really, really obscure cases of debugging things, but it sounds good in my head, so I want to try it. So those are the two things I would really change. They're both expensive, probably gonna, it's gonna be like at least $600 to get both of those. And that's, I got my eyes on some other stuff, like maybe some light replacements. And then, man, my next big thing is going to be a camera modification. That's not going to be fun. So yeah, those are both going to be almost as expensive as the gear I want, but I use more often. So anyway, that's pretty much it. Okay. I'm really excited about this. Yeah. All right. If you enjoyed this, you might want to subscribe. I'm definitely planning on doing some more electrical engineering type stuff. So yeah, there'll be more of that. If you want to support the channel and help fuel my purchasing of extreme test gear, you can find me on Patreon. But for now, that's it. And I'll see you next time for whatever shenanigans I get up to in this area.